continue on with some design process stuff, and then we're going to do a pretty fun class exercise. First thing I want to talk about is the project teams, and so we're going to have to announce the teams right after class, and the issue is we've got the enrollment down to 37 where it stands right now, and we need 36. I really don't want more than 6 people per team. But what's good about that is if I haven't talked to you, you're in the class. No problem. I think if we just go beyond 6 people per team, it gets too unwieldy and people can hide on the team and maybe not do as much. So I'm willing to do 6. I planned on 5, but I don't want to cut out another 6 people out of the class. So if that's cool with you, it's good with me. Is anybody still kind of shopping or maybe on the fence with this class? And it's okay, I don't take that personally. So is everybody pretty sure then that they're going to stick with the class now for the semester? Yeah, I know I'm asking you to like raise your hand and be embarrassed in front of your peers, but if you're on the fence, please try to make a decision, or please do make a decision this class period. And if you're going to drop the class, please grab me after class and tell me. Right? Because then it gives us a much better sense of the numbers. But other than that, I think we're all set for the teams. We gave most everybody their first choice, I think. Do you remember the numbers?
It's 27 first choice, 7 second choice, and 2 third choice.
Yeah, so pretty good. That was the best we could do. And we had to weigh like skill sets and background and all that stuff. So I think it'll come out pretty well. Okay. So now let's get started on design process stuff. So last time on Monday, I talked about taking a big problem, breaking it down into chunks, and building it back up into something. And that's kind of like the bottom-up view of the design process. And we also talked about the top-down view, where we have to keep envisioning like the final outcome of the design and how it would interact with users. So the process we're going to use in this class is kind of a variant of the two, and I think it's actually more built on the one used in 275 and kind of based off Ulrich and Eppinger as well. But in the class, you're going to start by trying to figure out what your design requirements are, right? This is going to be a really important part of your strategy presentations, which are the first ones in the class, and you're going to have to talk about what you want to accomplish in your projects. Then what we do is we explore a number of different strategies, and when I say strategy, I want you to think of a path towards a solution that is independent of an embodiment, right? And we talked about this last time. People will often say, like, the example I gave was a farmer will say, oh, I need grid electricity to pump water to my fields. Well, that might not be true. The requirement is he needs to pump water to the fields. The strategy could be a variety of methods. You could talk about like collecting water from water vapor in the air. You could talk about gravitational flow of water. You could talk about actively pumping the water. Each of those strategies that I'm saying right there doesn't give you a picture in your head of what the physical embodiment of the solution would be. So as designers, you should try to push yourself to kind of think higher level and explore strategies in a general sense, and then you can find a best one and then go into your concepts. So you're going to be doing that in your strategy presentations, and you're going to evaluate a number of strategies. And your strategies are how you will do what you want to do in your design requirements. But then those strategies become what you have to do to achieve how you're going to do it with your concepts. So when you go from strategy to concept, now you start thinking of like actual physical ways to solve your problems, right? So if we're talking about the farmer system and you choose pumping power, maybe solar pumping power, you can start thinking about like what would that pumping power system actually look like? And you can evaluate concepts. You'll do the physics, you'll do the conceptualization, you'll pick your best concept, and then you can see the pattern here that turns into what you're going to do with your modules, how you're going to solve your concept problems. So you will break your concepts into a number of different modules and pick which one is the most critical. That's this red one here, your MCM. So in the pumping system, your modules could be your solar power module, it could be the pump module, and you could have like a piping module, right? And the piping one's probably pretty straightforward. You might choose that solar panels are pretty straightforward. You could buy them off the shelf. But there might be a really tough challenge in the pump. and you choose that you're going to optimize your pump and design that as your most critical module. So then you're gonna again evaluate different solutions for each of your modules, pick the best ones, which I've shown in green, and then assemble those together into your final prototype. And that's what you're going to present in the final presentation. So these, 4 stages of this process all align with the milestone presentations that we'll do in the course. I want to talk about a bit this idea of a design trajectory, right? And it's so important to try to get your design requirements right up front, because if they're not, you can march down this path, you can do a really good design process, but you're going to end up maybe with something that's suboptimal. And the example I gave in the first class was like the Life Straw, right? That could be a beautifully designed product, purifies water, great. But if you went on this wrong trajectory, you might put all this work into kind of a bad solution, and you don't want to do that. So I think it's really important that you take the time to talk with your partners, really think through the problems, and figure out what are your core requirements and what is going to be the trajectory of your design process. Oh, and I showed the dog last time. So you set yourself on a good trajectory, your design can get better and better over time, and you can actually keep improving it through iteration, and you should keep doing that. Every time you go from like concept to module, you should kind of look back at your concepts and think about like, does this still make sense? Check yourself. And if you decide to bring this project on for like a master's thesis, or we've been talking about SDM's theses, or a UROP, or whatever, you very much may circle back, and that's cool. That happens in the design process. That's really, really good. So there's the general design process. You guys all read the Human-Centered Design Toolkit, right? What are people's thoughts about this? I wanted to have a bit of a discussion about this thing. Yeah?
I like the worksheets and sort of the operationalizing some of these concepts, because you get a lot of design toolkits that give you like a flow chart and a paper and they're handed off.
Yeah.
But I like how hands-on it was. At the same time, the trade-off is how applicable is that in every situation, how much are you just following the process versus thinking. But I thought that was a differentiator for this type of.
That's good. What do other people think? Yeah?
I thought the tips on brainstorming were pretty good.
Yeah.
There was like a warm-up brainstorming exercise where you sit with another person and they would throw out ideas and you would just shut them down. Do that for a couple minutes and then switch gears, and then they would throw out ideas and you kind of support them. You kind of could reflect on pros and cons of both approaches.
Cool.
It's an interesting idea I hadn't heard of.
Yep. Yeah.
Applying it to our project, I thought the hearing might be the big challenge, as being like, on a separate continent or whatever, so that may help as a challenge.
That's a really good point, because you guys are kind of locked here for the semester. And I think this is a point that I talk about a lot, actually, when I talk to other people in the field, because you very well may be in the same situation when you're working in a company. You may be working on a product abroad, and as the engineer, I think you're going to have to be cognizant of what maybe the marketing people are doing in the field, or maybe your local production guys in another area of the world are doing. And even though you may not be doing the ethnographic research on the ground, I think you should be thinking about like what might be critical issues in this problem, that we're trying to solve. So you're going to get content in this class that I don't think you can, readily use in your projects, but I think you have to be cognizant of it, because thinking about this content will make you ask maybe different questions to your partners. Because they might have the market insight that you would get out of this, right? So I think it's really important for you to think about these things. Yeah.
And I just wanted to add on to that, because also relating it to some experienced people that were designing like a bus to Europe, an electric bus to Europe, they were using Chinese components, and obviously when the people in Europe said, what's going to happen? We can't get these over here. Let's use these that we have over here. So getting the background of where you're designing the product from and what they have available there is very critical.
That's a really good point, and we're going to talk about that a little bit in a second further. Yeah?
I thought this tied in really well with the article about frugal science in a less direct way, in terms of accessing tools to the brain power and like the engineering power that's already over there, and where the solutions are going it's also relevant in other fields, like you see in education tech. People are like, I want to make education so much better, and then they make all these tools that aren't necessarily making a difference. So I think there's a lot of different applications, as well as like above and beyond $2 a day.
Mm-hmm. Yeah. Yeah. So, you know, the main premise of this thing is, in the 3 main chapters are hear, create, you know, deliver. And they show this kind of process of those 3 stages. And I had I think this is one of the only like written works in this space of like how do you go about designing this space. But I think there's some limitations, but they make sense when you think about them from IDEO's perspective. Are you all familiar with IDEO? Yeah, they're a big product design firm, probably the biggest in the US. And they're a consultancy, right? And you have to remember that when a company approaches IDEO, oftentimes they have a sense of the type of product they'd want to make. And IDEO will go into the field and understand like user needs and come up with concepts, comes up with prototypes. And when they have something pretty far along, they'll hand it back to the company. And the company will like do design for manufacturing and distribution and all that stuff. So, you know, some of my issues with this is when you're doing your observation stages, and I think you made this point, like you're going to observe the end user, but if you don't observe the parts supplier over in China, you might miss something, right? And so I'll throw a paper up on our Stellar page called Customer Chain Value Analysis. It's a really good paper by Krista Donaldson, and it talks about looking at all the different stakeholders that are going to play into a design and how you have to meet those needs. And in some cases, you're talking about like a corrupt government official who, unless he gets money in his pocket, you're not going to be successful, right? So I think you have to hear about more things in this stage than just the end users, and it may take more than a week. Right? This can be much more than a week. This can be months on the ground. And your next assignment is going to be reading Hidden in Plain Sight, which, you know, I think they allude to that in the book. And then the create stage, they really only talk about creating in a prototype sense, right? So what happens, like, how do you test it? What happens when it fails? Like, how do you iterate? How would you gather data? What analysis would you guys do as engineers to figure out what solution's better than others, right? So I think that's a missing gap here. And then deliver, you know, the story kind of ends, look, it literally ends at prototypes. Are you kidding? Like, what, you know, you're going to hear about our wheelchair on Monday, and it's like that's a 7-year-old project right now. We had prototypes after a year, but they sucked, and it took a long time to get it to market. So I think, you know, I wanted you guys to read this because I think it has some really good user-centered lessons. And I think IDEO deserves a lot of credit for like putting this in the public space and teaching people about it. But there's a lot more to it than what's said in this story, and you guys have to think about it. Another point too is they don't talk about companies at all. It's really an NGO perspective, you know, type document. But you know, there's massive companies like Tata who have been working in these markets for a long time that probably follow a similar type process, but certainly have to think a lot more in this space, right, to bring it to market. Okay, good. So a couple points I wanted to make, just some more general points about this, is, you know, I showed this slide in the first lecture about designing with and not for, and I think this really came out of, this really comes out of the Human-Centered Design Toolkit, but in this picture particularly, you know, when you're talking about who you're designing with, you know, we have an irrigation engineer here as well as a farmer, you know, as well as us. I think you guys can consider yourselves stakeholders, right? Say you're doing a doctoral thesis at MIT on a technology, like you are a stakeholder. Unless you get a degree out of that, it's going to fail. You know, you have to think about that. So subject matter experts that you choose, you know, I think it's really powerful when you can work with subject matter experts that really know the markets you're working in. And here are just a couple of companies. These are the companies we worked with last year, but I also work with these guys in my research group. But you know, what's powerful about these organizations is they already know a lot about their home market. And they've already demonstrated a track record of success in that market, so they've got a lot of insight. And I think they have more insight than you could ever get if you just go to the field for a week, right? these people know how to manufacture, like particularly these three. This is a $1 billion a year company. This is a $15 billion a year company, and the Tata Group is over $100 billion a year, right? They know how to make stuff and ship stuff. And in my group, and by and large in this class too, I like working with companies because there's an inherent economic viability that's built into their solutions. Because if they can't sell this stuff, they're not going to make money. They'll go out of business. But if they can sell more stuff and distribute it at a larger scale, they'll make more money. So there's like a nice feedback system there. When I talk to these companies, and when you guys talk to your partners, I think there's some key questions that you can ask to really help you out. And the first is trying to get a sense of their opportunity space, right? Like they may have a new market of non-consumers, like 2.5 billion farmers who don't use tractors right now. They may see that market, and you can ask them like, okay, where is there a gap in the market that they could fill, or where is there a new market, and then what is the barrier to them actually engaging that market? Yeah.
So one of the really interesting things that you find when dealing with experts, at least in my experience from the startup side of things, is experts are frequently biased. So the great sources of information, when experts can plug and build better code and not solve the hygiene problem.
Yes.
So you need to consider everything, but you also need to consider where they're coming from and their own interests.
Such a good point.
In that industry for so long, because maybe they're missing things that you pick up on.
Yeah, I completely agree with that. Yep, and yeah, you said it perfectly. They may articulate problems in terms of solutions and not really see like, independent of a solution, what could success look like in that market. In your case, better sanitation. When I say better sanitation, it doesn't say toilet, right? And I use this term a lot, like the technological keystone of the challenge. Like that's typically the basis of the projects in this class and the research in my group. Like we're helping these companies get over some hurdle, solve this keystone, make this keystone, and then they can plug that into the whole arch of the solution and make a real solution. Okay, so a big point here is listen, but I think as you said, listen with that ear towards bias. Okay, the next one I want to point out is you have to remember that even within a single organization, there may very well be a hierarchy of stakeholders within that one organization. And this example I really like using because it came out of our own experience in our group of interacting with Jane Irrigation. So Jane Irrigation makes drip irrigation systems. They're means of dripping out the exact amount of water you need on a plant, so you minimize water loss to evaporation and drainage. So up at the executive level, it makes a lot of sense they want to expand drip. It's their core business. They make more money. That's all great, right? And what I had to do then when I started engaging with this company is, I knew from the executives, like, okay, you want to expand drip, where are there new markets? Where are there gaps? Like where could we fill in? So talking with like the division managers, like the agronomists, I asked, could we irrigate with less water? Is that possible? Maybe we can reduce energy use, reduce water consumption by just making the system more efficient. And the agronomist said, no, you can't really do it. Our systems are already 85% or 95% efficient. So not a real opportunity there. But as I talked to the flow guys that do the flow networks and the power guys, what I understood was that the really big market, and it was really the conversation with both these guys, the really big new market for drip irrigation is off the electrical grid. And why that's such a hard market to engage is that once you go off the grid, your pumping and power system costs about $3,000 to $5,000 per acre, right? And so it's like, it jumps the system cost by 10 times, makes it exorbitantly expensive. So talking with the power and flow guys, I was like, whoa, why do you need so much power to pump the water, right? And the power guys are like, well, you need that much power, so our system's really expensive. You need about 1 horsepower per acre. And then the flow guys said, well, we need to pump at a high pressure so we can maintain a relatively uniform pressure down the line so we get even flow rate out of each dripper. Because as you start pumping at lower pressure, your pressure drop down the line becomes relatively big compared to your pumping head. So you may get like 1/10 the pressure at the end as you do up to the pump. And then your water flow rates are all off. So we started to understand if we could somehow lower pressure, then we could lower power, then we could make the thing cheaper. We also had to talk to the production engineers and understand like why some of their products are so expensive versus so cheap. So they make a lot of products out of low density polyethylene, and they can pultrude it, they can injection mold it, super cheap. But the drippers they make now that are able to experience a range of pressure but maintain constant flow rate, they all use a silicone diaphragm as like a bendable flow restrictor, and that adds a lot of cost to the system. It actually like is half the cost of the overall dripper. So we knew like, you know, some price sensitivity there. And then talking to the distribution guys, you know, we could understand what could a farmer afford and pay back over maybe 1.5 years or so, how would it be used in the field, and how do systems fail. So it was really only through combining all the viewpoints of this hierarchy were we able to understand that if we could drop the pumping pressure down to 0.1 bar, right? We cut the pumping power by 10 times and cut the cost by 10 times, and we could make a $300 system for 1 acre, which would right now cost $3,000 to $5,000. To do that, we knew we needed a pressure compensated solution. And what that means is a dripper that can experience a variety of pressures but maintain a constant flow rate. We knew the price point of each dripper because we need about up to $5,000 per an acre field, so 2.5 cents each was the limit. And we knew that if we could make it clog resistant by having it have large internal flow channels, that we need less filtration, and filtration causes you pressure loss and capital cost, right? So there's an incentive to make it like bigger channeled. So that was really cool. That said, you know, here are our core requirements, right? And the moral of the story is it like took talking to all these guys. And you guys might have to talk to these, you know, people within your respective partner companies, or ask your point of contacts there to get some insight from these people. So, you know, think about that hierarchy. But the story didn't end there. Like the craziest part of this story is that, you know, this is another part. We did the engineering analysis with their engineering division to figure out that a 50-watt system, instead of like a 700-watt system for an acre, would be viable if we can hit these performance points. But the craziest part of this whole story was we were putting together a proposal for the Rockefeller Foundation, and we were talking about the piping Jane Irrigation uses. And they have two standards that they use. A thick-walled tubing, it's kind of a rigid tube, and a thin-walled tubing, which has less plastic in it, and it's kind of like flexible like a garden hose. But it has less plastic, and as a result, it's a little cheaper. So obviously we wanted to use the cheaper one, right? We want to make a really cheap system. And we talked about this with the executives, and they said, no. You can't use that thin-walled tubing because we can't get subsidies for it. So actually for the farmer, it's cheaper to use the more expensive thick-walled tubing, right? Totally irrational from our standpoint, and an example of how we could have made a mistake at that point in the project by using the thin-walled tubing, that, you know, we could have developed an idea for years and years and years, only to find out when it goes to market, no way we could sell it because it's too expensive, because it doesn't tap into the subsidies. These guys know the Indian government subsidy structure for agriculture. I never will, right? And so that's why it's so important to tap into them. Yeah?
Is that subsidy structure you plan on it being the same though when it reaches market?
Well,
Is that something that's going to be maintained?
that's what we asked too, right? And Jane has been around for 30 years, and they said we have had great influence on how the subsidies are formed, right? They were confident. You know, and I had to go with their you know, judgment of this situation, but they were confident that that subsidy would still be there, or they could influence it. Yeah, but they're the biggest, you know, the biggest in India by far, second biggest in the world for drip irrigation. The other funny thing about this, you know, and I have that arrow coming down from the user, is that we were also talking to Jane, and they said, well, farmers like the thicker walled tubing actually because when bullocks step on it, bullock is like an oxen, it doesn't puncture, but the thin walled punctures, right? And I like this example because it's really the top of the hierarchy and the bottom of the hierarchy impose the same constraint. So, and we would have missed it had we not been thinking about that whole hierarchy. Okay, so the moral story here is listen. Listen to people. Okay, an idea that I want to talk about, and this ties into the stakeholder chain analysis, which I'll post on the website. I'll show a picture too in the next lecture of that too. But I'm going to talk about in the next lecture our wheelchair. This is a picture of it, the Leverage Freedom Chair, and I think this is a design process that we use in my group, and kind of an approach we use in my group, and I think it ties in really well with the human-centered design toolkit. That when you're making a solution, it's really your end users, right, who are, I would say, kind of your primary stakeholders, because they're the ones who are going to say, hey, I've got this problem in my life that's not solved, and they're the ones in the end that are going to say, hey, this solution actually meets my needs, right? And as you create a technology, it's going to evolve through like innovation and then validation. And you guys are mostly going to be in this phase, in this semester. But validation, commercialization, and distribution, right? And I think it's really important to consider the different stakeholders that you're going to have to get on your team in order to get around this circle. So in this project, in the early parts, it made sense that we had a bunch of academic folks working on this. So, I was at MIT and the Singapore University of Technology Design and IIT Delhi and worked with folks from all those places in the early stages of this project. And we could come up with prototypes and test them and break them and get data. And it really made a lot of sense to have academic groups working on the innovative side of the project. But MIT doesn't make or ship any products itself. Right? We're in the business of making prototypes, not products. And there's this huge chasm, I think, a lot of times between the prototype that would come out of academia and the product that is ready to be commercialized. So to bridge that gap, we had to do a couple things. We teamed up with Continuum, which is actually a competitor of IDEO, but it's a Boston-based product design firm, and we had to start up a company. Global Research, Innovation, and Technology. And I have 3 former students that work for that full-time right now, selling the Leverage Freedom Chair. But having a company, the company could do things like shipping logistics, quality control, marketing, like all these things that aren't really academic in nature, but have to be done in order to get over to commercialization. Then we had to team up with a manufacturing partner, and we work with this company called Pinnacle Industries. They're an OEM bus and truck seat manufacturer in India. And so they make welded steel frames that are upholstered, and so they're pretty similar to a wheelchair. And they're well positioned to make our chair. And so now they're able to make 500 chairs a month. They set up a pretty big manufacturing facility. And then to distribute, we teamed up with the biggest disability group in the world, Jaipur Foot, right, to really understand and get connected into distribution networks. So the moral of the story here is I think this project has worked well, and we've this year was really the first year we've gone into production. We've sold over 1,200 of these chairs, so business is picking up pretty well. But I think we've only been successful because we thought about this chain of stakeholders that would take us all the way from inception of the idea all the way to implementation in the real world, and we got them together on the same team, and they helped us get back here, right? Yeah?
So were you tracking with all of them right from the beginning, or?
Yeah, that's a great question, because now in my group, we start right from the beginning, right? And if you work with, say, Tata will occupy this whole space, right? They can help you validate it. They can certainly manufacture it and distribute it, right? But in my group, we definitely try right from the start to identify who are going to be all these players to get it out to market and get their feedback early on, because they're going to impose constraints and requirements on the design. In this project, we didn't start at this scale right from the get-go. We started working with more smaller scale wheelchair manufacturers and distributors, but we did have a really good sense of the financial aspects of providing wheelchairs, and we were able to hit a price point that positioned us well in the global wheelchair provision market. And I'll talk some more about that too in the next lecture when we do a more in-depth case study on this. But that's a really good point. Yeah?
How do you get funding for the steps after research education?
We ended up winning Mass Challenge, which is the largest startup competition in the world. And so that gave us a good chunk of change. We've taken some investment You know, we were kind of scrappy students for a while. We lived in D-Lab for a little bit, actually. You know, we still use their workshop because they can't use my lab because of the conflict of interest, but they can use theirs. Yeah, so we were scrappy about it. We did a lot of this work as students, but we were pretty small. It was just one person and me to start with. I was a postdoc at MIT, so I didn't cost the company anything. You know, so we just had to raise the salary for one person, and we grew from there. Yeah, it is a good question though, because there's not as many funding sources for that kind of early startup, you know, stage of a company. There's more for like when you've got the finished thing and you want to distribute 1 million of them, you can go after like the Gates Foundation. And if you want to do like kind of more conceptual validations, there's like the NCAA, which is a Lemelson Foundation branch. But yeah, I'm actually working with the American Society of Mechanical Engineers to create funding mechanisms for this space. We're trying to do that right now. You know, kind of the $500,000 type grant area. Good question though. Okay, and yeah, this was the point I made when I said Tata can occupy this whole space. Yeah, for example, we're working with Jane. Jane has great testing labs and testing farms. Like they have these experimental farms that we can just tap into, and they manufacture and distribute at massive scales. Okay, cool. So how are we doing on time? Perfect. All right, so the design challenge I want to do with you guys today is I want you to think about how you can make a human-powered blender. Is this possible, right? And when I say human-powered blender, I don't mean this, right? So this is something you see, I've seen around in developing countries, you know, and it's a blender hooked to the back of a bike, so you got a guy pedaling away, you spin your fruit and stuff. No, I mean a real blender that you could keep in your kitchen. Right? You could use by one person, you could store it on a shelf, it's light enough that you can lift it on the shelf, and it's pretty cost effective. So, do you guys think this is possible? What do you think? Where would you start with this? You know, yeah.
First, you need to find out what problems you're trying to solve with it.
Yeah, and I've kind of limited that here a little bit, right? So I'm putting you forward a little bit. You know, this is an engineering exercise that we're doing right now. Yeah.
Both products you want to blend, how much torque it takes to blend them.
Yes, good. And lo and behold, guess what we have in here? A blender, right? So how could you find out how much power a blender puts out? Yeah, exactly. Oh man, you guys got me. I was hoping you'd say some like hard calculation, but no, you can just look on the underside. In this one, it says it is rated for 450 watts. Okay. But what is that? Is that electrical or mechanical power? Okay. So how much mechanical power do you think it is? Yeah, that's a pretty good guess. Oh, by the way, just an aside, right? You could turn this thing on. No, don't do that. Chop your fingers off. I'm actually going to turn the lights on so you can see more of this. All right, so we got 450 watts, and so can you still see that well enough that we can write on the board and you can still see that?
Yep.
Is that okay? Okay. Yeah, okay, so I started, I'm going to turn that off so you can see it. You know, I started this by cracking open the blender and looking at what type of motor, and it's called a universal motor, right? Really, really common AC motor, and the efficiency of those is around 50-ish%. Right, so we're talking about 225 watts of blender power. Okay, so let's write that down. It's 225 watts, and that's mechanical. Okay, so is that a lot of power? You know, kind of. I showed you that human power curve in the class. Is that more power than you may need?
Yeah.
Maybe, okay. So we're going to explore that a little bit. But first, I want you guys to get a sense of how much power could you actually put out if you had a device, you know, like that meets these performance requirements. So what we've done is brought a bunch of kitchen tools. right? Comparative devices. What? Oh yeah, thanks. It's not full of water yet. So anyway, you can actuate all these. We've got all sorts of stuff. We've got a French press. We've got water if you want it. And so what I want you guys to do is break up into teams, probably about 6 people each. And I want you to estimate how much power you can get out of these devices. Each team should choose a device. Here's a bunch of spring scales. Here's a real scale that you can push on with force. Let's see, we got all kinds of fun stuff in here. So real scale, and we've got stopwatches. Cool, stopwatches. We've got this thing, which is missing a bottom, I think. Yeah, I think it goes like, there we go, like that. This is a cutting thing. What else? We've got an egg beater, ice cream scoop, a melon baller, garlic press, all kinds of fun stuff. I know. Martha Stewart does engineering. All right, whoops, if you can grab that. So anyway, take the next 10 minutes and figure out how much power you can get out of these things. Go for it. Split up into teams. You could probably do it by row, actually. Yeah. Grab some stuff, and we will write down how much power each of you can get. Oh, we have a tachometer?
Oh, dude. We don't have a wine. We don't have a wine.
You take whatever you want.
Yeah, go for it.
Yeah, we have a tachometer too. No, there's no more in here. All right.
Everything. They didn't share. Entire bag of spring scales.
They'll figure it out.
Now